Let P be -2, 4, 0, -1 and Q 5, 1, -3, 2. We want to determine 3P minus 4I plus PQ. So that's 3 lots of -2, 4, 0, -1. Take away 4 lots of the 2 by 2 identity, which is 1, 0, 0, 1, plus -2, 4, 0, -1, multiplied by 5, 1, -3, 2. So this first one is going to be -6, 12, 0, -3. And then we're going to have 4, 0, 0, 4. And then we need to do the multiplication. So to get top left, we do top times left. So -2 times 5 is -10. Add 4 times -3, which is -12. So that would be -22. Then we do top times right. -2 times 1 is -2. 4 times 2 is 8. If we add those, we get 6. Then we're going to do the bottom times the left. So that 0 times 5 is 0. -1 times -3 is 3. And then bottom times right. 0 times 1 is 0. -1 times 2 is -2. So, looking at the top left elements, I've got -6. Take away 4, so I'm on -10. Take away 22 is -32. For top right, I've got 12. Take away 0, so I'm still on 0. Add 6. That's 18. For the bottom lefts, I've got 0, 0, add 3 is 3. And bottom right, -3. Take away 4 is -7. Take away 2 is -9. Determine the value or values of the constant t for which the matrix given here is invertible. That means that we can produce an inverse, and that means we need the determinant to not be 0. So the determinant here is t plus 1 multiplied by t minus 2. So t plus 1, t minus 2. Take away 5 times 2. We need that. Let's find out when it's 0, and then it's going to be not those values. So that's t squared minus t minus 2. Take away 10 equals 0. So t squared minus t minus 12 is equal to 0. So that's going to be t take away 4. T plus 3 is equal to 0. Giving us t is 4 or t is -3. So that's when the determinant is 0. So we just need t to not be 4 or t to not be -3. We now want to show use of a matrix method to solve the system of equations 10x plus 6y plus 3 is 0 and 3x plus 2y minus 1 is 0. Let's write those as 10x plus 6y is equal to -3 and 3x plus 2y is equal to 1. So we can set that up as a matrix by doing 10, 6, 3, 2 times xy is equal to -3, 1. We need the inverse of this matrix here. The determinant there is 10 times 2, which is 20. Take away 6 times 3, which is 18. So the determinant is 2. So it's going to be a half. And we're going to swap the leading diagonal and take negatives on the other diagonal, like so. So we've got a half of 2, negative 6, negative 3, 10 times 10, 6, 3, 2 times xy is equal to a half 2, negative 6, negative 3, 10 times negative 3, 1. On the left-hand side, all of this just becomes the identity matrix, and so the left-hand side just becomes x, y. On the other side, we're going to have a half, and then let's do some expanding. So top times this matrix. So we've got 2 times negative 3 is negative 6, and negative 6 times 1 is negative 6. If we add those, we get negative 12. And then using the bottom, we've got negative 3 times negative 3, which is 9. And we have 10 plus 1, which is 10. And so that is going to be 19. And so xy is going to be negative 6 and 19 over 2, or if you like, 9.5. So x equals negative 6, y equals 9.5.